Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy very Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Tangled Arrows by PageDough. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have digits along an arrow line sum to the digit in the attached circles. Arrow lines are colored either blue or gold to assist in distinguishing tangled arrows. And these are arrows that are tangled because I'm not really sure. It's just basically they are tangled. But that's the theme, obviously, for this puzzle. So, for example, I assume that because the arrow goes here, then here, then here, then here, the sum of the digits here plus this plus that, and that again must equal the digit that is here. Or you also have the gold arrow here. So say this was a 3 and a 2, then this would have to be 5 because these two digits add up to what this digit in the circle is. The sum of the digits along a gray double arrow line is equal to the sum of the digits in the circles at the end of the line, at the line's end. So, for example, if, say, this was, I don't know, 6, 4, and 5, this adds up to 15, and say this was 7, then this would have to be 8. Because these three digits on the arrow, the double arrow line, must sum up to the digits, the sum of the same sum that the two end circles add up to. So this 6, 4, 5 adds up to 15, 7, and 8 add up to 15. Therefore, that satisfies the double arrow line rule set. We also have cells joined by an X sum to 10, cells joined by a V sum to 5. So these are typical XV rules. We also have digits joined by a white dot are consecutive. That's typical white Kropke dot rule set. And not all X's, V's, or dots are given, which just basically means there is no negative constraint. So for example, if this were a 3 here, this would have to be a 2, and this would have to be 7, because these two digits must add up to 5, and these two digits must add up to 10, because of the X in between here and the V in between these two digits. And if this digit were, say, a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get it started. Let's learn how to Sudoku. Okay. First thing first, all the V's have to be 1 through 4. So these are 1 through 4. That adds up with 6 through 9 to add up to 10. So this is guaranteed to be 5 here. And then this is at minimum 1 and 2. So that's 5 plus 3, which is 8. And then you have another digit here. So therefore, that forces this to be 1. So this is 1. This is 4. This becomes a 1, 2 pair, which eliminates 1 and 2 in the rest of the row. So this cannot be 1, 2. It's 3, 4, which adds up with 1, 2 to add up to 5. 3, 4 adds up with 8, 9 to add, 6, 7 to add up to 10. 1, 2, and 3, 4 add up to 5 here. And 1, 2 with 8 and 9 adds up to 10. So this is 4 plus 1 or 4 plus 2, which makes this 5 or 6. This has to be 9. This cannot be 1, 9, cannot be 4, 6. Okay, the 1 here eliminates 1 here. So this is 2, which makes this 1. So this adds up to 5. This is 1 then and 9. 1 and 4 add up to 5. So that makes this 3 and 2. 3 and 7 add up to 10. This cannot be 1, 9, cannot be 2, 8, cannot be 4, 6 because of the 1 in the column, the 2 in the column, and the 4 in the box. So this must be 3 and 7. That leaves the remaining digits in this box in the upper right corner as 2, 8, and 6 because of the 3, 7 pair in the box. Okay. This cannot be 9. So it's at most 8 here. You have, this is 1, 2 at least, 1, 2 at least here, and then 1 more. So it cannot be 7. So this is 1, 2 plus 1, 2, that's 6, plus 1 at least, which is at least 7. So this has to be 8 then. So this is 8. This is 3 digits adding up to whatever that digit is. So this is 6 through 9, but cannot be obviously 8 because of 8 in the box. So this must be 1 through 6 here, no 5. This can't be 2 or 3. So it could still be 1, 2, 3. So if this is 1, this is 9. If this is 4, 6, this is obviously 4, 6. You can't have a 6 here. This is at least 1, at least 4. So this can be at most 1, 3. And we're guaranteed a 1 has to be here and a 1 has to be here. So again, at most 1, 3. Therefore, this can't be 1. So this is a 4, 6 pair here. Interesting. That eliminates 4 and 6 in the rest of the row. If this is 1, this can't be 1 here. It's 4. This can't be 3, because if this is 3, that means this is 1, 2 at minimum, plus 3 twice. That's already 6, plus 3 is 9. So this cannot be 3. So this can't be 2 then. Okay. Same here. This digit cannot be 9. It has to be at least 1, 2 plus 1, 2. So this is 7 or 8 here, which means this could be 1 and 2 at most. To add up to 8, you could go 1, 3, potentially. 1, 2, 3. This is guaranteed to be 1. This is guaranteed to be 1. 1, 2, 3 plus 7, 8, 9 adds up to 10. This cannot be 7 because of the 7 in the column. So this can't be 3. This is either 1, 2 adding up to 3, 1, 3 adding up to 4, which is not allowed, or 2, 3 adding up to 5. So this has to be 3 then. So this is 3, which makes this a 1, 2 pair, adding up to 3. These are consecutive, so you're guaranteed a 2 here. Okay. Remaining digits in row 4 are 5 through 9. And this can't be 5, so this is 6, 7, 8, 9. This can't be 8 because of the 8 in the column. So this must be 1, 2, 3, 4. And this can't be 2 because of 2 in the row, so this can't be 8. So that's 6, 7, 9 there. This is definitely a 1, 2 pair, which eliminates 1 and 2 in the rest of the column. So this cannot be 1 or 2. It's 8. This can't be 2 or 8. It's 6, which makes this a 2. This 8 eliminates 8 here, so it's 7, which means this must be 1, 2, 1, 2 plus 1. So this is 1 here. That makes this 2, 1, 2, which makes this 9. So again, 1, 2, 2, 1, 2, 1, and 1 add up to 7. 2 eliminates 2 here, so this is 1. This can't be 1 or 2, so that makes that 3, which makes this 4. 3 eliminates 3 here, so it's 7, 3. This can't be 1 or 3, so it's 2. This can't be 2 or 3, so it's 1. So then 2 plus 1 plus 3 plus 1 plus 1 adds up to 8, which is correct. This 4, 6 pair eliminates 4 and 6 here. So this has to be 7 or 9 here. 4 here eliminates 4 and 6 as a possibility for this column. Okay. This can't be 7 or 8. It must be at least 1, 2 plus 1, 2 plus another 1. So this is definitely 9. So these 3 digits add up to 18, which is what 9 and 9 add up to. It has to be 18 minus 2 is 16, so this must be a 7-9 pair. Oops. So this is a 7-9 pair, which eliminates 7-9 in the rest of the box. So these two add up to 15. 15 minus 2 is 13. You don't have 7 or 9. That eliminates 4, 9, and 6, 7. So that leaves 5 and 8 in the rest of to add up to 15. Okay, let's see. This cannot be 1, 9 because we have 1 eliminated. We have a 9 in the box. Can't be 2, 8 because of the 2's in the rows. Where is the 2 actually in row 7? It cannot be here because of the 2's in the boxes, so it has to be here. So this is 2 with 1 or 3 here. We're not sure which. We're guaranteed a 2 here. This could be 3, 7 or 4, 6. We're not sure which. If this is 3, 7, this is 3 and that's 7. Otherwise, this is 4, 6. We have a 7, 9, 7, 9 pair in column 2, which eliminates 7, 9 in the rest of the column. We also have a 7, 9, 7, 9 pair in row 4, which eliminates 7, 9 in the rest of the row. This can't be 7, 9. That can't be 7 or 9. Remaining digits in row 1. 5, 8, 9. 8 cannot be here, so this is 5 or 9. This is 5, 8, or 9. Where's the 9 in this box? Cannot be here. It must be one of these two. So that eliminates 9 in the rest of the rows. So this is 5, which means this can't be 5 here. This is 8 or 9. This 9 eliminates 9 here, so this is 8, which makes that 9. This 5 eliminates 5 here. Remaining digits in row 2 are 7 and 9. So it's a 7 or 9. Remaining digits in this upper left-hand box are 3 and 6. Remaining digits in these two cells are 2 and 5. And this can't be 2 because 2 in the column. That makes this 5, which makes this 2. 5 eliminates 5 here, so that's 8 and 5, which means this can't be 5. That's 6. This can't be 6. That's 8. Okay. 9 here eliminates 9 here, so it's 7 and 9. 7 eliminates 7 here, so it's 9 and 1. So this cannot be 1 here. This 9 eliminates 9 here, so it's 7. Therefore, these 3 digits add up to that digit. 7 eliminates 7 here, so it's 9. This must be 4 then, with 1 and 2 adding up to 7. That leaves that as a 6. Okay. Remaining digits in column 7. We have, what, 3 and 5? Remaining digits in column 6. We have 3 and 4. This can't be 3 because of a 3 in the box, so this is 4. That's 3. 3 eliminates 3 here, so it's 2, which makes this 1 and 2 to be consecutive. So this is already 1 plus 2 plus 1. That's 4. So 9 minus 4 is 5. These two digits must add up to 5. It cannot be 1, 4. It must be 2, 3. This can't be 2 because 2 in the column. So this is 3. That's 2. 3 and 2 add up to 5. 3 eliminates 3 here. So it's 6 and 3. This can't be 3 and 7 then because of the 3 in the column. This 3 eliminates 3 here. So this is 5, which makes this 3. And the rest we learn from Sudoku. Remaining digit in column 2 is 8. Actually, let's just do, how many 1s do we have? We have 8 1s. We know where the last one has to be. It has to be there. 1, 2, 3, 4, 5, 6. We have all 9 2s. We have 8 3s. So we know where the last 3 has to be. It has to be here. 4s are probably, yeah, it's still We still have a potential lot of areas where 4 could be. In the left central box, 4 cannot be here, so it has to be here because of the 4 in the row. That's all we have. 5s. Where's 5 in column 3? These are filled out. Cannot be here because 5 in the box, so 5 has to be there. We don't have any other information about 5, though. 6s. Where's 6 in the central box? It has to be here. We don't really have much more information there. 7, where's 7 in column 1? It has to be there. Where's 7 in row 6? Cannot be here because of the 7 in the column. Therefore, it must be here. We have where's 7 in column 3? It must be there. So that means we have 8 7s. The last 7 has to be there. 8s. Where is the 8 in row 5? It has to be there. Where is the 8 in column 8? Cannot, these are all filled. This is filled. This can't be 8, so this must be 8 there. And we have 8 8s now. We know where the last 8 has to be. It has to be there. So now 9s. We have 8 9s, so we know where the last 9 has to be. It has to be there. So we've already done 1s. We've done 2s. We've done 3s. 4s. Do we have any additional information? Yes. In column 4, the 4 has to be here. In column 9, where can the 4 be? Cannot be here because 4 is in the boxes. Can't be here because of 4 in the row, so it must be here, which makes this 6, which makes that 4. That gives us all the 4s. The 5s should be, yeah. In column 9, 5 cannot be here, so it must be here. That means 5 cannot be here in column 5, so it must be there. And that means the remaining digits should all be 6s, I believe. And that's the solution. Yeah, pretty straightforward. I did this because you don't usually see arrows going back on itself. And then there's also the double arrow concept, which you don't see very often. So I like to use this sort of as an introduction to these sort of concepts that you could potentially run into. You don't, as I said, you don't see arrows essentially doubling back on themselves very often, so it does introduce a little bit of interesting mechanics. And the double arrow also is interesting too, so keep those things in mind when you do other Sudoku puzzles. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.